I'm going to start your notes for IVT, Intermediate Value Theorem. And so before we get into the actual what's on your page, I just have a quick question for you. So I have drawn a function on the board, and I've covered up part of it to see if you can kind of guess what do you think's happening under there. So most of you are like, oh, well, you're covering up the x-intercept. Well, maybe I am. I could be covering up the x-intercept. So some of you are thinking that perhaps underneath here, that's what it looks like. And it could. It could. So most of you would say, oh, well, I think that there is an x-intercept probably around x equals 4. Did you ever stop to consider that maybe, just maybe, I drew a discontinuous function? So maybe it doesn't cross the x-axis at all. So if I gave you this and said, is there an x-intercept? Before answering my question, I think you would need to come back with a question of your own for me. So I ask you, is there an x-intercept? You need to ask me, well, that depends. Is the function continuous? And if I say, yes, it is continuous, then it's safe for you to answer, yeah, there has to be an x-intercept. Because if the y values of my function were negative here, and my y values of the function were positive here, yeah, it had to. My y values were negative, and then my y values were positive, and the function's continuous, it had to, like, continue through the x-axis. The only way that it wouldn't have an x-intercept is if it were discontinuous. Okay, so now I'm going to start on your notes called IVT. It's called Intermediate Value Theorem, not IVT. IVT, Intermediate Value Theorem. I have to set up. I've tried to do the best that I can with lighting in here and videoing and all that. So, hope it's working out for you. All right, Intermediate Value Theorem says if your function is continuous. So the other day, yesterday, the notes that you watched before this one, we talked about how do you know if a function is continuous? Well, you just kind of know. Like polynomials are continuous. Root functions are continuous where they're defined. So they're continuous in their own domain, and so on. So if a function is continuous and you're looking at a closed interval, well, that's kind of confusing. Let me just start with this. Show that there is a root. Well, by root I mean solution, x-intercept, or 0. You know that that's what those are called. When it crosses the x-axis, it could be called x-intercept, 0, solution, or root. Show that it crosses the x-axis between x equals 1 and x equals 2. So in this picture, it would be kind of like prove that this function crosses the x-axis between 3 and 5. Well, now we're proving that this function crosses the x-axis between 1 and 2. So what I want you to look at, I want you to look at y values that occur when x is 1 and y values that occur when x is 2. So plug in 1 to your function. You can do the math, or you can just take it for granted that I did the math. So plug in 1, I get a y value of -1. Plug in 2, I get a y value of 12. So here's what we know so far. 1, 2. At +1, my y value is -1. And at +2, x equals +2, my y value is 12. Don't you think that your function, if it's continuous, don't you think your function had to continue through the x-axis to go from a y value of -1 to a y value of 12? Absolutely it did. Is your function continuous? Well, it's cubic, it's a polynomial, of course it's continuous. So that's really pretty much it. I'm just going to write out my answer. So, and that's what the intermediate value theorem says. It says if you've got a negative y value on one end of your interval and a positive y value on the other end of your interval, as long as your function's continuous, it had to continue through the x-axis. So, here's what I'm going to write. Since f, calling my function by name, since f is continuous, you don't have to say how you know. You don't have to say, I know it's continuous because it's a polynomial, and all polynomials are continuous. Since f is continuous, and since this y value was less than 0 and this y value was greater than 0, by the intermediate value theorem, there is a root somewhere in this interval. Now, I can even kind of take it a step further and say, you know what? I know that there's a root in here somewhere. I know it's not at 1, and I know it's not at 2. I know that. See, I didn't get 0 anytime. So you could even kind of narrow your interval down a bit and say, it has to be somewhere between 1 and 2, not including 1 and 2. Either way, the direction said show that there's a root somewhere between 1 and 2. We did. And the important thing is get your y values, okay? And since this is negative and this is positive, you know that y has got to be 0 somewhere in between here. We have stated our function's continuous. We stated we've got the whole below 0, above 0 thing. We've got by intermediate value theorem, and we state where there's a root. State that it's continuous. Give me your inequality, intermediate value theorem. There's a root. Okay? That's it.